Welcome, dear students. Now we discuss 2021 MCQ Metric Spaces and Complex Analysis paper CC-13 semester 6 B.Sc Honours in Mathematics, University of Calcutta. Question paper 2021 question 1a. Let xt be a metric space and A be a subset of X. Choose the statement which is not true. Correct is this: delta A meet B equal to delta A intersection delta B, where delta A denotes boundary of A and DAB denotes the distance between A and B. Let us consider usual metric space RT, where dxy, this metric dxy equal to the modulus of x minus y, where xy belongs to the set of real numbers R. Let A equal to 0, 10 be an open interval, and B is the open interval 5, 15, be two open interval 0, 10 and 5, 15. The open subsets of R. Clearly, the set of all boundary points of A given by delta A is the set 0 and 10. There are two elements in this set. And delta B, the set of all boundary points of the set B. That is means this open interval 5 to 15, 5, 15. So this set contains only two elements 5 and 15. So delta intersection delta B is the pi, because between these two sets there is no common points, so this pi null set. Now A intersection B, and this is the 5, 10, this open interval, and this A. So delta boundary points A intersection B is 5, 10. This set contains only two elements. So obviously delta intersection B not equal to delta A intersection delta B. So this statement is not true. Next question. Question 1b. Two matrices D and D star are defined on R2 as follows: x cap x1 y1 y cap x2 y2 belongs to R2. Then dx cap y cap equal to x1 minus x2 whole square plus y1 minus y2 whole square whole to the power half. And d star x cap y cap equal to the maximum between modulus of x1 minus x2 and modulus of y1 minus y2. Then which of the following is true? Correct option is 2. D and D star are equivalent. Now D star x cap y cap less than equal to D x cap y cap less than equal to root 2 D star x cap y cap for all x cap y cap belongs to R2. Now we have the following theorem: two matrices D1 and D2 on a non-empty set X are equivalent if there exist real numbers alpha, beta, not greater than positive, greater than 0, such that alpha D1 less than equal to D2 less than equal to beta D1 for all xy belongs to X. So here this point is x1 y1 x2 y2, so this distance is d, root over of x2 minus x1 whole square plus y2 minus y1 whole square. So this is the hypotenuse, and this distance x2 minus x1 and distance x2 y2 minus y1. So obviously this is 3, say for example this is 3 and this is 4 for example, and this is 5, this is d. So obviously 5 is greater than 4, and this 4 is less than 5 is less than root 2 into 4. Root 2 into 4 means 5.7. So just consider this example. For this relation, this term means this term means maximum and minimum of this distance, this. So this term less than d2. d2 is this x1 minus x2 whole square plus y1 y2 whole square whole to the power half. So this we get this relation, d star is less than d, less than root 2 d star. From 1 we get alpha equal to 1, beta equal to, from this theorem, beta equal to root 2 and d1 equal to d star and d2 equal to d. Clearly, d star and d are equivalent matrices. Question C, let A is the set of all those order pairs xy belongs to R, x not equal to q, rational numbers, y not equal to q, either x not equal to rational number or y not equal to rational number. Then which of the following is true with usual metric on R2? Correct option is 3. A is neither open or nor compact in R2. Now we have the theorem, every compact set is bounded. It can be easily seen that set A is not bounded. This set A, xy belongs to a real number, either x irrational or y irrational. When x irrational, y rational, or x is irrational, y rational. So xy belongs to real number, x does not belongs to q, so either x equal to irrational or y is irrational. So obviously this set not bounded set, so this set A is not compact. Let us take a point A, this A1 A2 belongs to capital A set. Let us choose A2 not equal to Q. So A2, choose A2 irrational. If we take any open ball around the point A, we can always get a point B equal to B1 B2, this such that both B1 B2 either rational or irrational, and due to the density property of rationals and irrationals in R. Thus, the set A is not open as this point A belongs to A is arbitrary. No point of A is the center of some open sphere content in B, because this point B either both rational, so this point B does not belongs to the set capital A. So this set A is the not open set, open interval open set. So A is neither open nor compact. This 1C. Question D. Consider R2 with the usual metric. A is the set of all those order pair 1 by n, 0 belongs to R2 such that n belongs to the set of natural numbers n, union thus the set in singleton set 0, 0. And B, set B is the set of all those order pairs x, sine 1 by x belongs to R2 such that 0 less than x less than 1. Then which of the following is correct? The correct option is 3. B is connected, A is disconnected. Here, A is the set of all the order pairs, this 1 by n 0. So x y by 1 by n 0. So suppose 1 n equal to 1. So this point is 1 0. This point is 1 0. Next n equal to 2. So 1 by 2 comma 0. This 1 by 2 comma 0. 1 by 3 comma 0. So these points on the x-axis, and this sequence of points moving towards this origin O, union this origin O. So all these points 1 0 1 2 half 0 1 by 3 0 1 by 4 0 and 0 0, and there is a gap between 2 points of it. So from 1 to half these points there is a gap. No real number, no points. This belongs to the set A. Obviously A is disconnected. Now the set B is x sine 1 by x. So x and sine 1 by x, if we draw the graph by any application, Desmos or others, this graph is this sine 1 by x, this graph up to 0 to 1. Interval is this 0 to 1, so 0 is excluded and 1 is excluded. So obviously this fx equal to, if fx equal to sine 1 by x, then clearly fx is continuous in this open interval 0 to 1. And so any 2 points on this graph can be connected by a path. So this is path connected, and this fx is continuous, and in this interval 0 1 and 0 1 interval is connected. Hence fx in this interval 0 1 is connected, so B is connected. Next question, E. Let A be a subset of a metric space XD, then X belongs to capital X such that D X A equal to 0 is, correct option is 2, equal to A bar, but not necessarily compact. But not necessarily compact. Let A be a subset of a metric space XD. Let S be a set such that X belongs to capital X, such that DXA, distance between the point X and the set A equal to 0. And S, the set is not equal to 5. Then DXA equal to 0 implies that the implied by is infimum of DXA, such that small a belongs to any element of the set capital A. This, by the definition of this distance, this d infimum of dxa equals to 0. This implies and implied by this, for all epsilon greater than 0, there exists a point A belongs to the set capital A such that dxa is less than epsilon. This because this infimum dxa equal to 0, so obviously by the knowledge of analysis, this dxa is less than the epsilon. And this implies and implied by for all epsilon greater than 0, there exists A belongs to the set A such that A belongs to this open sphere S epsilon x, centered at x, radius epsilon. So S epsilon x intersection A not equal to 5. At least one point small a belongs to the set A. So obviously this intersection not equal to 5. This implies and is implied by x belongs to A bar. A bar, this A union A dash. Set A union the set of all limit points. This is derived set. So this closure. So this A bar is the A union A bar. So obviously S equals to A bar. S equals to A bar. So this equals to A bar, but not necessarily compact. Consider an example A. This set A, this 0 infinity, 0 to infinity, this interval, including the point 0, then S equals to A bar, send to A. gives an unbounded interval, this A bar obviously is not compact. Hence, the correct option is this, not necessarily compact. It's not bounded interval, so it is not compact. Next question. F. Let Tz, Az plus B whole divided by Cz plus D be a bilinear transformation, then infinity is a fixed point of T if and only if correct option is 3, C equal to 0. If C equal to 0, D not equal to 0, from this transformation put D equal to 0, then Az plus B by Cz, sorry, C equal to 0. So Az plus B by D. So this A by D into Z plus B by D. This is equal to alpha Z plus beta, where alpha is the A by D and beta equal to B by D. This from 1, this relation 1, it is clear that T infinity equal to alpha infinity plus beta. So alpha is some number A and A by D, and beta is some number B by D. So this real number A by D, B by D. So this T infinity obviously this is equal to infinity. Infinity plus beta is infinity. And hence infinity becomes a fixed point. Fixed point, what is fixed point? If Tz equal to Z, then Z is called fixed point of T. Then T infinity equal to infinity, and hence this if C equal to 0 is the condition, if and only. Next question, G. Let Fz equal to the mod Z square, this Z belongs to the set of all complex number C, then F is the differentiable only at Z equal to 0. Very important question. Actually, this question is that if Z equal to mod Z square continuous everywhere, but nowhere differentiable except the point at Z equal to 0. So this mod Z square is everywhere continuous and differentiable only at the point Z equal to 0. So let Z equal to x plus iy, xy real, and I squared minus 1. And this fz equal to mod Z square, so this is x square plus y square. Obviously, this is a continuous function, continuous everywhere for any xy. Now, f dash a is the, by definition, limit delta z tends to 0, f of a plus delta z minus f a by delta z. A is a complex number, and provided this limit exists, put the value of f a plus delta z, this a mod of a plus delta z square minus modulus of a square. Now, modulus of z means z into z bar. So a plus delta z, a plus delta z whole bar, that means a bar plus delta z bar, and this mod of a bar, a square equal to a into a bar. So after simplifying, we get simplification. After simplification, we get a bar plus a delta z bar, a bar delta z plus delta z bar minus a bar. Cancel this a bar and divided by delta z, whole divided by delta z. So a delta z bar by delta z plus a bar plus delta z bar, because delta z not equal to 0, tends to 0, not equal to 0, so we can divide by delta z. So this equal to f dash z equal to limit delta z tends to 0, this a bar plus delta z bar by delta z. This because delta z bar tends to 0 at delta z tends to 0. If a equal to 0, then from this right hand side, a bar equal to 0 and this a equal to 0. So obviously f dash 0 equal to 0. So a is differentiable at the point z is equal to 0. Now let a not equal to 0 and let delta z equal to this rho cos phi plus I sin phi. Then delta z bar equal to rho cos phi minus I sin phi. So delta z bar by delta z equal to this cos to phi minus I sin to phi. The limit delta z tends to 0, delta z bar by delta z, this is not equal to a unique limit, because this limit depends on the phi, is the argument of this uh, delta z, argument of the delta z depends on argument delta z, and also delta z bar. So this we cannot find the unique limit if a not equal to 0, and hence fz is not differentiable for a non-zero value of z. Next question, h. The radius of convergence of the power series summation 4 plus 3i whole to the power n z to the power n, correct option is 1 by 5. Let a n equal to 4 plus 3i whole to the power n, so that limit tends to infinity modulus of n whole to the power 1 by n. So this n, so cancel 1 by n, so modulus of 4 plus 3i, so 4 square plus 3 square whole root over, it is equal to 5. The Cauchy-Hadamard formula, this 1 by r equal to limit supremum n tends to infinity modulus of n whole to the power 1 by n. So r equal to 1 by 5 is the correct option, radius of convergence of this power series. Next question, I, the value of integration over C, contour C, unit circle, center at origin, sec z dz, correct option is 2, 0. Here the unit circle, center at origin, radius is 1. So always we traversing the anticlockwise sense, this C. Now sec z equal to 1 by cos z. Clearly sec z is analytic at all points except cos z equal to 0, because if cos z equal to 0, so 1 by 0 is undefined. So this sec z is analytic when cos z equal to 0, except at cos z equal to 0. So that at cos z equal to 0 means at z n 2n plus 1 into pi by 2, or n belongs to the set of all integers z. So the poles, this when denominator is 0 for this z equal poles, this z0 say, this put n equal to 0, this 5 by 2, n equal to 1, 3 pi by 2, n equal to minus 1, minus pi by 2, this 1.57, this 4.71. So these poles all lies outside the unit circle, but none of these poles lie inside the unit circle modulus z equal to 1. So integration over the contour C, fz dz equal to 0. Because fz is analytic and fz is continuous inside and on the simply closed curve C, and so by Cauchy's theorem we get integration for C fz dz equal to 0. Next question, question J, the last question, 2021 MCQ. I is the integration of gamma z square dz, where gamma is along real axis from 0 to 1 and along the line parallel to the imaginary axis from 1 to 1 plus 2i. Which of the following is true? Correct option is this minus bracket 11 plus 2i by 3. From real axis, gamma is this path, this along real axis from 0 to 1. So this 0 to 1 and 0, 0 to 1, 0. So this path is this 0 to 1. And next, the path imaginary axis along parallel to the imaginary axis from this 1 to I plus 2i. That is by order pair notation, this 1 comma 2, that is 1 plus 2i. So L to M. So first we travel from 0 to L, then L to M. So along OL, obviously y equal to 0. on the x-axis. So dy equal to 0 and x varies from 0 to 1. So integration of our OL z square dz, put here z equal to x plus iy, so dz equal to dx plus I dy, and then put y equal to 0 and dy equal to 0. So this we get x square dx, integration of our OL, that is x equal to 0 to 1, x square dx, so 1 by 3. Along L to M, this x equal to 1, because on this line segment always x equal to 1, only vary y, varies y from 0 to 2. So dx equal to 0, x constant, so obviously dx is 0, and y varies from 0 to 2. So integration of our ln, this z square dz, so z square is this x square minus y square plus twice ixy into dx plus I dy. Put here x equal to 1 and dx equal to 0, so we get x equal to 1 minus y square plus twice iy, this I dy. So after simplifying, I into bracket y minus y cube by 3, after integration minus 2 into y square by 2, I into I square minus 1, y equal to 0 to 2, so we get minus 4 minus I into 2 by 3. So total integration is this OL plus ln, integration of our OL plus integration of our ln, that is 1 by 3 minus 4 minus I into 2 by 3. So we get minus 11 plus 2I by 3. Thank you for watching this video.